In this video, we're going to talk about conservation of momentum again, but in this time in inelastic collisions. So an inelastic collision is one where there is maximum loss of kinetic energy. Still important to keep in mind that momentum is still conserved. Now, an inelastic collision can easily be recognized because the objects tend to stick together after they collide. Okay, so here's an example. We want to find the recoil velocity of a 70 kilogram ice hockey goalie originally at rest who catches a 0.15 kilogram hockey puck slapped at him at 35 meters per second. And then we also want to compute how much energy is lost, how much kinetic energy is lost during the collision, assume friction is negligible. Okay, so we start with conservation of momentum, and we're going to take the mass of the puck, which is 0.15 kilograms, times its velocity, and the goalie is originally at rest, so his momentum is 0. And then after the collision, the puck sticks in the goalie's glove, and so it's got a mass of 70.150. That's just the sum of this and this times V2. So we solve for V2 here, and we come out with 7.48 times 10 to the negative 2 meters per second. So this is an inelastic collision, and so maximum kinetic energy is lost. So what we want to do is to figure out exactly how much kinetic energy is lost after the collision. And we're going to do that by finding the difference between the kinetic energy before and after the collision. So here's the kinetic energy before. We take the 1/2 times the mass of the hockey puck times its velocity squared. Recall that the goalie was at rest, so it doesn't have any kinetic energy. So this is 91.9 joules. And then after the collision, we have 1/2. Remember now that the mass of the goalie and the puck combines here. And this was the velocity that we computed in the previous slide in part A. So we work through and we find out that the kinetic energy after is only 0.196 joules. So you can see there's a big difference here. So the kinetic energy lost is just the difference between those two numbers, and that's 91.7 joules. So most collisions fall somewhere between elastic and inelastic. Remember, elastic is no loss of kinetic energy. Inelastic is maximum loss. Many times collisions, as we say, fall somewhere in between. So if you take, for example, if you ever played pool, the two balls hit each other, they collide, and you can hear the click as the cue ball hits one of the other balls. So just hearing the click lets you know that some of the energy is lost. It's converted into sound. So that's got to be a partially elastic collision. Or two cars colliding. So two cars colliding, sometimes when the cars collide they do stick together, but oftentimes they may bounce off, and so in that case that's a partially elastic collision as well. Remember that all collisions, whether they're elastic, inelastic, or partially elastic, all that has to do with kinetic energy. Momentum is always conserved in all three of those types of collisions.